anything they need help with, I can help you with it. Okay, so here's the side splitter theorem at the top. It says if a line is parallel to one side of a triangle and intersects the other two sides. So in this diagram, RS is parallel to the side XY in the actual triangle, so it's parallel to one of the sides of that triangle. What's going to happen is that's going to cut that into proportionally congruent sides. All right, so the sides are going to be in proportion here. So I don't necessarily love the way they wrote the theorem, but basically like this little piece XR over this little piece from R to Q, just down the same side. I just literally like turn those two pieces into a fraction. And then if you go down the other side, that's why it's called a side splitter, you would have QS and then SY. And these are in proportion to each other. And we'll do this in a problem in a second and it'll make more sense, but literally you can just go down the side to create a fraction on either side of the parallel lines here, and then you can set them equal to each other. It's the side splitter theorem. Okay, like I said, don't worry about the proof. If you're really interested, I will be happy to go back and show you how to prove it, but this is going to be the case for any question you guys might run into. Now I'm going to just have us focus on seeing if we can do a couple of these problems. Now, you're looking for, if you're going to use the side splitter, two parallel lines. One line should be parallel to the other side in the triangle. So I've just got two parallel lines. You literally just go down the side. So I'm going to go down this side to create a fraction, and then I'm going to go down this side to create a fraction, and I'm just going to set them equal to each other. So it's just the piece that's 8 over the piece that's 10. Just down that side of the triangle. Literally think of that parallel line as being the division sign in your fraction if you want to. And then I'm going to go down the other side. So I'm going to have 6 over x. That's how the side splitter theorem works. Now you'll notice, right, the 8 and the 6, those are both cut off at the top. So those are both in the top of my fraction. The 10 and the x, those are both cut off by that parallel line and the base of the triangle. So those are in the same part of the fraction. There's different ways you can set these up. I could do like 10 over 8 equals x over 6. That would give me the same thing. But I just go right down the side, make a fraction, do the same thing on the other side. Then you're just going to cross multiply, divide. So 6 times 10 would give you 60. 8 times x give you 8x. Divide both sides by 8. And x is 7.5 here. Yeah, go ahead. Yeah, just if you want to put a decimal or a fraction, whatever's easier for you. I'm probably just going to use decimals. Okay. So kind of same thing here. You've got parallel lines. Bless you. Just go right down the same side and literally like think of that parallel line as being like the fraction bar. So I would do a over a plus 4. Now, I'm not saying anybody was going to do this. You cannot cross the a's out in this fraction. Anytime you have a plus or a minus with terms, like I have a plus 4, you cannot cross the variables out. You can do that if you have multiplication only, but as soon as you add an addition sign or subtraction sign, can't do that. All right, and then the other side is the 12 and the 8. So I'm just going to put 12 and 18. 12 over 18, these diagrams are not drawn to scale very well. Just when you do this problem, don't forget, if your cross products have a couple terms, like I have a plus 4, you got to do a little distributive property. So if I do 12 times a, I'd get 12a, and then plus 12 times 4 is 48. My other cross product is just a times 18, so I would write 18a. And then it's up to you guys, but I like to try to keep my variable positive if I can. So I would just try to subtract 12a from both sides, give you 48. And then 18 minus 12 will give us 6 a's. And this will be a nice number because 48 divided by 6 is 8. Okay, now I have one more, and this one looks a little bit different. But I would tell you here, the parallel lines are actually kind of going kind of diagonal here, so it looks a little bit different than the other two problems we just looked at. And there's different things you can do with these questions. Easiest thing I could tell you to do here is see if you could tell me what the length of that little piece is that's cut off by the parallel line. So they're telling you this whole side is 45. This much of it's 30. What would this little piece be? Perfect, 15. Just 45 minus 30, that's 15. Okay, now, and then let me just, I'll tell you what, I'm just going to turn my paper just a little bit so it's a little easier to see. So I'm just going to go down the side. So the 30 and the 15, those are cut off by the parallel lines. So I would have like 30 over 15, and then the 10 and the x. You could reduce these if you guys want to, but you don't have to. You could just cross multiply right there. This is going to end up being 30x. 15 times 10 is 150. And you're just going to divide both sides by 30 there. And you'll just get 5 as your x value. Did I screw that? Yeah, you could do 15 over 30 equals x over 10. Yes. Yeah, you can flip it over for sure. And especially a picture like that, you maybe you turned it like maybe if I turn my paper this way, you get the same answer though. Like I could do x over 10, 15 over 30. Either way, they give you the same answer. You can do that, yeah, if you want to do smaller over larger, larger over larger on top, smaller on bottom, whatever. Both would work. As long as your cross products are the same as mine, we should be good. Okay, is anybody having a question? All right, now, I'm going to have you do me a favor on this one. So just the example I've got there, just kind of cross that out real quick. I want to give you a little bit different picture. This is not drawn to scale, but there's a question like this on the homework, so I want to go over a question like this. So I just drew a triangle and then just tried my best to draw a line that looked, I'm not constructing this or anything, but just two parallel lines. That is a 6. Sorry, it's a 6. It totally looks like a B. All right, so the intention here, this piece is supposed to be 6, and then they're going to tell you the whole side is 8. And then this piece is x, and the whole side is 16. Okay, I'm going to show you two different ways to do this problem. One of them I personally think is a little easier than the other, but it's kind of weird. All right, so I've got my two parallel lines. Now, you can do this in different ways here, but let's say I had this that whole side is 8, right? So the whole side is 8. And this piece of it is 6. All right, and then what I could do the other whole side. You can use the side splitter this way too. The whole thing over this piece. So the 6 and the x are both cut off by the same line. The 8 and the 16 are both cut off by the top and bottom of the triangle. You could set that up. That's personally probably the fastest way, because what I'm going to show you next is a little bit harder. But just cross multiply divide. So it doesn't have to be in a specific order. You could do the whole side over the piece. That will work as well. Bless you. Now, if you don't want to do it like that, what you would have to do for the side splitter would be to determine these two pieces that I don't have labeled. All right, so I'd have to determine this piece and this piece to kind of do what we were doing, more similar to what we had on the front. So this one's easy, right? Because this whole side's 8, so this would be 2. This piece is a little bit harder because the whole side is 16, and I can't just subtract x and get a number because I don't know what x is. So this piece right here would be an expression, and it would be 16 the whole side minus that piece, which is x. So this is just another option. If what I just did, if that doesn't make sense, that would work what I just did. Or you can do kind of what we did on the front, a little bit more similar to what the theorem looks like. Something like 6 over 2 equals x over, and then the expression would be 16 minus x. Both of these will give you the exact same answer. It's just two different ways to do it. So if I cross multiply here, I'm going to get 8x. 16 times 6 is 96. And if you divide both sides by 8 there, and my drawing is not to scale, x would be 12. If you did it this way, you'll get the same answer. It's just going to be one more step because I've got to do a distributive property. So I'd have 2x for one of the cross products. The other cross product, I'd have to do distributive properties. So 6 times 16 is going to give you 96. 6 times that negative x would be minus 6x. And then it's just one more step that the previous way I showed you, one more step than that. I would add 6x here, and then you'd get 8x equals 96 again, which is what I got. So that's where x is going to be 12. So just two different ways to do the same problem. But as long as you've got portions on the same side cut off by the same parallel lines, you should be okay to set up different types of proportions. Is anybody having a question? I'm just trying to give you options. I'm not trying to confuse you. Okay. Now, this question here, I thought this was a really good question, and there's problems like this that I feel like come up. So here's a diagram over here, and I do have two parallel lines in this diagram, so I could use the side splitter here. So here's what the question says. It says a classmate says you can use the side splitter to find both x and y in that diagram. Okay, what do you think is wrong? It says I can find both x and y. Can I find both x and y using which variable can I not find using the side splitter? X. Okay, thank you. Now x is actually one of the parallel lines. All right, so you can't find x with the side splitter here. Now, you can still find x, all right? You can still find x. If I've got two parallel lines in a diagram like this, right? This angle and this angle would be corresponding. This angle and this angle corresponding, congruent. Angle at the top would be the same in both of those triangles. You could, and if I was going to find x here, I would recommend separating, but I do have similar triangles here. So this would be 2y and x. Now this whole side would be 5. This would be 7, and this would be y plus 2.4. Now, if I was going to find y, I would use the side splitter because I could go right down the side. But to find x, I would have to use similar triangles. So you can still find it, it's just not using the side splitter theorem. So just to keep that in mind. If I was going to find x, I'd tell you for the similar triangles, the 2 and the 5 would correspond to each other, x and the 7. That's how I would find x. You can use the side splitter to find y, just not x in that question. Okay, is anybody having a question? All right. Now, this is really the same thing as the side splitter. It's just not specifically for a triangle. So a corollary, which is what this is, to the side splitter, it basically follows that theorem. And so it doesn't have to be a triangle. These are just pictures that have parallel lines and transversals. Okay, so this is going to say, and you got to have 3 or you can have more. So if you got 3 parallel lines, right? And I've got 2, or you could also have more. It just kind of depends on the question. I got 2 transversals here. If you go down the transversal like you would just go down the side of the triangle, it's going to split these proportionally. So in the little diagram to the side, like A over B, I'm just going down the transversal, A over B and B over C. That goes down that same transversal, just like the side splitter. I'm just putting them into a fraction. And then on the other side there, I would have like W to X. And then the other piece that's cut off there would be X to Y. You can set those up proportionally, sorry. So, like in a drawing here, right? The 4 and the 5 are both cut off by the same parallel lines. The 6 and the x are both cut off by the same parallel lines. Just go right down the transversal to make your fraction. So 4 over 6 would be equal to 5 over x. The 4 and the 5 are cut off by the same parallel lines. The 6 and the x are set up to be cut off by the same parallel lines, and I just cross multiply, divide here. This is going to give you 30 equals 4 times x. So in that little picture, x would be 7.5. So just go right down the transversal and make your fraction from that. Okay, I got some a little bit more complicated diagrams. That's kind of just the most basic case. So I've got a little bit more complication down here. Now I have 3 parallel lines, and I've got 3 different transversals here. How could I maybe set up a proportion to figure out x in that diagram? The parallel lines are going to cut the sides off in proportion. What do you think? Okay, true. Can I solve that? True statement. You could set that up from that picture. Problem is I got 2 different variables there, so that's not going to help me find either one. This would be a little bit tricky. Can anybody see it? Maybe another proportion I could set up? Yeah. Okay, now you guys look at this. So this is true. I just can't solve it because I don't know x or y. But if you use this line here that's more in the middle, the x and the 30, and then the 15 and the 26. Bless you. So x and 15 are cut off by the same 2 parallel lines. 30 and 26 are cut off between the two. This is just going to allow me to solve it because it's actually got numbers. Now, when you guys do this one, this does not have a nice answer. So I'm going to get 26 times x. 15 times 30 is 450. And if you guys get like a nasty number, so like I'm just going to do 450 divided by 26. If you get a nasty number when you're doing this, just round to 1 decimal place, the nearest tenth. So I'm just going to call that 17.3. And you can actually use that exact same, that 15 and 26, to find y. Just that 16.5 over y, that would be equal, that same thing, 15 over 26. If you look back at the diagram, the 15 and the 16.5, those are cut off by the same parallel lines. The 26 and the y, both cut off by the same parallel lines. This one's a little bit nicer. If you do 26 times 16.5, I'm going to get 429. The other cross product would be 15 times y. And if you divide that guy by 15, y is going to be 28.6. And I'm not rounding that. That's an exact, if you check that out on your calculator, it's exactly 28.6. Okay, now this one. This is going to be a situation where I've got 4 parallel lines here. So the parallel lines are all horizontal. This is tricky. Could anybody set me up a proportion to find x in that diagram? Could I find x? Thomas, what do you think? Perfect. Okay, just 6 over x, right? And then 5 over 12.5. Just go down the same side. That's why it's called the side splitter. All right, so just 6 over x equals 5 over 12.5. Cross multiply here real quick. We're going to get 5x, and 6 times 12.5 is 75. So divide that, x will just be 15. Okay, now, if you have something like, if you have x, if you want to put that back into the diagram, you could use that. Without using x, could you tell me how to find y in that diagram without using x? Amelia, what do you think?
6 over 9 equals 5 over 9.
Perfect. Okay, they don't have to be connected to each other. Like 6 over 9, both of those pieces, 5 over y. So there's kind of a gap in between those. They don't have to be touching. You can use, as long as they're cut off by the same parallel lines, you're good to go. So something like 6 over 9 equals 5 over y. Just cross multiply there. 9 times 5 will give you 45. 6 times y give you 6y. And if you divide those by 6, I think this is 7.5. I feel like that's been an answer to like 5 questions today. All right. And I want to give you two options for this last question here. Okay, I'm going to give you two options. Kind of like the problem at the top. Okay, so use which one ever makes more sense to you. All right, do you guys see I've got these parallel lines here going vertically in this question. And I have between the top and bottom parallel line, that whole piece is 25. All right, so, or sorry, far left and far right. Could you tell me between those two parallel lines what that distance would be on this side? 20. Okay, so you can do this. I gave you two options here. This is how I would do it because it's less work and I'm lazy. All right, so the whole side is 25, and then down that side, the piece that I don't know is Z. All right, down the other transversal, the whole thing is 20, and the piece that matches up with the Z is 12. So you could do it like that. Or, now, if I do basically just the side splitter and don't use the whole piece, if I just use the actual parts that are cut off by the parallel lines, this is another way to do this. You would have to tell me what this piece is as an expression. It's a little bit tricky. The whole thing is 25, this much of it Z. So this piece here would be 25 minus Z. All right, now if I do it that way, I'm just gonna kind of ignore the 25 and the 20 that I put down there. So down one of the transversals, I'd have 25 minus Z over Z. Down the other transversal, just to make them match up, the 8 would correspond to that 25 minus Z, so it would be 8 over 12. Now, both of these will give you the same answer. So if you do 25 times 12, you get 300. 20 times Z would be 20Z. And you're just going to divide both sides by 20. So Z is actually going to end up being 15. If you like this other way better to write the expression, the cross product 12 times 25 would give you 300, and then it'd be minus 12Z. The other cross product would be 8Z. You would add the 12Z to get all your variables on one side. And you guys will see I got the same, I got 300 equals 20Z, divide both sides by 20, you get 15. Same answer, just two kind of options for you to do it. As long as you're consistent, there's a bunch of different ways you can set these proportions up. Is anybody having a question at the moment? Okay, I'm going to